One more thing today. This is the K level part. I don't even teach this in L level. This is kind of counterintuitive. A segment of a circle, when it's of a circle. A segment is the part of the circle, I'm just reading this off, bounded by the arc and the segment joining its endpoints. So we have a chord. And we have an arc, whether it's major or minor, and the shaded region between that chord and that arc is called a segment. And I know it doesn't look like a segment, and no, it is not one-dimensional. It's an area, it's 2D. But this is a segment of a circle, so it's not a plain old segment. This is just what it is. So that is a segment. Now, how are we going to find the area of a segment? Think about it. How are we going to find the area of that shaded region? Yes, Abby. So here's how we're going to find the area. First, we're going to draw radii. We're going to draw these so that we can form a sector, a piece of pie. So we're going to find the area of the sector. We're going to find a sec. Then we're going to find the area of this triangle, area of a triangle. And then we're going to subtract them. And when you find the area of the piece of pie minus the area of the triangle, then you'll get the area of the segment. It's called a segment. Crazy, huh? So sector minus triangle. I'm going to give you a minute to write this down if you're taking notes. Let's see if we can put this to use. Find the area of the shaded region. So we're going to find the area of that peach region. And the way that we're going to do that is we're going to find the area of the sector, and then we're going to take away the area of the triangle. So let's get started. Let's find the area of the sector. To find the area of the sector, we're going to do A sec over A equals M over 360. I hope I'm not going too fast because we've already learned this. Let's wait for the screen to catch up because there's a major lag. There we go. So 100 times 90 divided by 360, and we get that the area of the sector is 25 pi. Now let's find the area of the triangle. Now, we started off with an easy one because I gave you a right triangle. It's not only right, what else is it? Because this is a radius, and this is a radius, these triangles that we draw, they're always going to be isosceles because these triangles are always made up of the radii. But they're not always going to be right isosceles, but they will always be isosceles. So the area of that triangle is base times height divided by 2, and so it's minus 50. And that is the answer. It looks like we have those the wrong way, right? Like, ooh, I should switch those. But no, you should not. 25 pi is greater than 50. So the answer is 25 pi minus 50. You don't subtract them, you don't combine them, you don't do anything unless the problem says to round. You might want to put units on it. It would be inches squared because it is an area. Okay? Find the area of the shaded region. Same strategy. A sec minus area of the triangle. So we are going to do A sec over area equals M over 360. Huge lag, sorry. 36 times 120 divided by 360. So the area of the sector is 12 pi. Now we're going to find the area of the triangle. Now remember, this is isosceles. It is. Because it always is. But we cannot just do 6 times 6 divided by 2 because the height is not 6. So we're going to have to get creative here. We're going to have to draw the height in just like that. So if you want to redraw the triangle facing you, you can. Remember that the measure of an arc is equal to the measure of the central angle. We need that measure or else we can't find the height of this triangle. Now, when I take 120 and I draw the height in, what happens to the 120? It's bisected. So this is 60 This is 90, and this is 30. Oh my goodness, you thought we were done with those. Okay, so anyways, what is the height of this triangle? Are we okay with the height being 3? So now we need our base. Our base is a lot. It is. This is 3 root 3, and this is 3 root 3. So the base is 6 root 3 times height divided by 2. So those 6's, those weren't the base or the height. Okay, is it showing up? It's being so slow. So what would that be? 9 root 3? (12pi minus 9 root 3 is the answer. Now this is looking like the area and perimeter unit. Oh no. It won't get any harder than this one. I mean, I promise. Okay. So please make sure that you try your homework, especially try the ones on your homework that are segments, because we obviously have the toughest time with that piece of it. Tomorrow, you better ask me questions. We'll go over questions, and we'll move on. Tomorrow is tangents. You will like it better than area of a sector, I promise.